Before you call me crazy, look at the math. Right now, the AI industry is a financial black hole. OpenAI is losing up to $130 million per day. And that fancy cloud subscription that costs you $200 a month, well, it can burn up to $5,000 of compute power. They are losing money on purpose just to keep the hype going. And this is not getting any cheaper. The most recent Claude model, Mythos, is 5 times more expensive to run than the previous one. And if new models are several times more expensive than the ones before, it doesn't matter if they're better. At some point, it's just too much. It's just too expensive. Put that together and you get a brutal conclusion. The current strategy of AI companies, more GPUs, more data centers, more power plants, is economically and physically unsustainable. It just burns through too much energy and money. But you probably already heard that AI is a bubble. So what does all of that have to do with trees? And here's where it gets really interesting. The training of GPT 5.4 used enough power to fully charge every iPhone in the world 4 times. Energy is clearly the bottleneck. But instead of trying to solve efficiency first, we build even larger data centers. Take another look at Clusia. It doesn't have a power cord. It figured out how to do complex computation for free 3.5 billion years ago. And your brain uses 20 watts of power. That's less than a light bulb. Yet it does your homework, it writes emails, it draws images, and it recognizes your mom's face instantly, basically for free, without needing a whole data center. A data center running GPT 5.4 needs several megawatts, 1,000,000 times more power to do a fraction of what your brain already does for the price of a coffee. So here's the real question. Why the hell are we still building chips out of melted sand when we could just grow them out of living cells? There are already lots of companies working with AI in biology, including companies like Cortical Labs that created a dish brain made out of human brain cells. In February 2026, they got 200,000 neurons to actually learn to play the game Doom. Yes, they ran Doom on brain cells. Of course, these brain cells need to be nourished with nutrients, and they currently have to be contained in a box. This can't replace silicon computers just yet, because if you compare those 200,000 neurons with our brain, which has 86 billion neurons, that's 430,000 times more. But we can do even better. Just using brain cells in currently still expensive boxes that supply those 200,000 neurons with nutrients, that's an impressive breakthrough. But what if we didn't use brain cells? What if we instead designed our own biological cells for the sole purpose of serving as a super efficient computer alternative? Think about that. Another breakthrough in science is Evo2, which was published in Nature in March 2026. And it's trained on 9.3 trillion nucleotides, and it can analyze DNA sequence up to 1 million DNA base pairs. And then it can tell you where the mutations are and how deadly they will be. But more importantly, it can generate new sequences. This means it can generate bacteria with 580,000 base pairs. These organisms were experimentally validated and they actually worked. And Evo2 is, by the way, completely open source. Our human DNA has 3.2 billion base pairs. That's still 6,000 times more than the bacteria. So growing a few 100,000 neurons in a dish is one thing. Designing a whole new organism from scratch, that's something else entirely. So we have brain cells that can play Doom. We have an AI that can design life from scratch. Now, what does all of this mean? What if you combine them? If this progress continues, at some point we could be able to create a whole new species, a whole new DNA that's as complex as humans. Or we could program cells to do whatever we want. Imagine if you could just design a brain computer for your needs and then just grow it. And AI like Evo 2, but far more advanced, could design a custom organism with its cells optimized for computation that take properties of brain cells, mycelia, bacteria, whatever helps fulfill its purpose. And then with custom fluid transportation for cooling and nutrient delivery, like custom bloodstreams, and with maybe chloroplasts to pull energy directly from the sunlight. You put the blueprint cell into a nutrient bath with sugar, and 3 days later, ta-da, you have grown your own computer. No GPU factories, no shipping them across huge distances, using tons of energy for producing chips and toxic waste. It just could be so much more efficient. And why stop at computers? What about houses with walls that photosynthesize, decentralized and autonomic energy production, installation that grows like bark, floors of living moss instead of a carpet, or skyscrapers designed by AI, grown from a single cell and replicated indefinitely. Of course, this is very dangerous. 200,000 neurons playing Doom is a fun headline, but if you scale that to 86 billion, a full human brain equivalent, or even further to trillions of cells, suddenly you're not building a computer, you're building a mind, and that raises questions that we are nowhere near prepared to answer. Is it conscious? Can it feel pain? I don't know. Evo 2 stripped virus DNA from its training data, and that's smart. But the model weights are public, the architecture is public, adding the data back in is not that hard. And a sufficiently motivated person or government could train a version of Evo 2 that designs novel pathogens, viruses that have never existed, or bacteria that no antibiotic can touch. Innovation has always been driven by conflict. And as nuclear weapons become less usable, the next frontier of warfare is biological. So why not train an AI model capable of producing biological weapons, viruses, deadly bacteria to kill your enemies? An AI that can design custom organisms is by definition an AI that can design custom weapons. So if an evil person got hands on this technology, it could have catastrophic consequences. Biology evolved over billions of years, and less than a cubic meter of DNA could contain all of the knowledge of the whole world. Fats, glucose and ATP are a lot more effective for storing energy than using lithium-ion batteries. Evolution figured out all of that by itself. And if you build a whole ecosystem with an AI agent that was trained on all of that, think about it. A human can grow into a human form with a specific structure just based on their DNA. And if any kind of DNA with similar or higher complexity could be designed by an AI, the possibilities are endless. If you grew a new super intelligent computing species with trillions of cells, this being would be more than 1,000 times smarter than a normal human being. And what happens after that, I don't know. But what I know is that this scenario is not unrealistic. This isn't fantasy. Every piece of the technology I just described already exists in some form. Like, we just haven't connected them yet. And I think this is definitely doable in the next 10 to 15 years. Whoever controls this technology, whoever gets there first, becomes effectively unstoppable. Guys, I'm a little bit scared, but the next time you see a plant, don't just see a plant, see a blueprint. Because whoever figures out how to read that blueprint won't just change computing. They will change what it means to be alive. This is the kind of future I think about constantly. If you want to see more videos exploring the weird and terrifying edges of science and technology, hit that subscribe button. It helps more than you think. Thanks for watching and see you in the next one.